Bismillah Rahman Rahim. In this session, we will discuss section 4.3 electric circuit for another subject of O-level physics, also for IGCSE students. For this physics course, we have chosen this book of Tom Duncan and Heather Kennett, 2021, and published by Hodder's Education. This is very popular book, and here we have some test yourself on page 212 from this book. Here we have a question: if the lamps are both the same in figure 4.38, and if ammeter A1 reads 0.5 ampere, this one 0.5 ampere, what do amperes A2 and A3, A4 and A5 reads? So this is a battery source, and this ampere meter will measure all the ampere that these two loads will carry. So the ampere will A1 will read all the amperes, and if the current will divide into these two paths. So whatever the current that flows through A1 will divide into A2 and A4, and the same current will flow through the A5. So whatever is flowing through A4 will flow through the A5 as well, and this is load, this is a lamp. Similarly, for this A2 and A3 will read the same ampere meter reading, and this A1 will read the addition of these two amperes. So A1 will read 0.5 amperes as given, and A2, A3 will read half of this ampere, because this same type of assuming that both the lamps are same. So this current will divide into two parts. So this 0.5 will divide into 0.25 and 0.25 ampere, and the same current will read through this, because this is in series. A2 and A3 are in series, A4 and A5 are also in series, same path, and these two loads are connected in parallel. This path and this one are connected in parallel because these points are common. So A2, A3 will read 0.25, and A4 and A5 will read 0.25 ampere. So this is simple. Question number 2. 3 2-volt cells are connected in series. This is 2 volt and this is 2 volt. After this another voltage is source is connected. So this 2 volt and 2 volt is equals to 4 volt. So what is the potential difference at the terminal of the supply? So across this terminal, this to this, there will be 4 volt. How many joules of energy does 1 coulomb gain on passing through a 2 volt cell? So this is the amount of energy that will gain if 1 coulomb charge is passed through 2 volt cell. So this is 2 volt cell, this is 1 coulomb. So this is 1 coulomb, and 2 joules is 2 volt is 2 joules. So 3 cells connected in series. Now instead of using this 2 volt cell, we are using 3 2 volt cell. So this is 2 volt, 2 volt, 2 volt. So this is 6 volt. So instead of this 2 volt, we will use 6 volt. So 1 coulomb and 6 volt is equal to 6 joules. So this is part 2. Now put this into practice on page 212. 3 resistors of value 4 ohms, 6 ohms and 8 ohms are connected in series. So this is 4 ohms, 6 ohms and 8 ohms. So connected in series. So this will be addition, simple addition, 4, 6 and 8. So this, the total effective resistance or combined resistance will be 18 ohms. A 4.5 volt battery is connected across two resistors of values 3 ohms and 3 ohms plus 6 ohm. Calculate the current flowing through the resistor. So the voltage source of battery is 4.5 volt. Resistance is 3 ohms plus 6 ohms is equal to 9 ohms. This is the total because the resistors are connected in series. So this is 3 ohms plus 6 ohms is 9 ohms. So I is equal to V upon R. Voltage is 4.5 volt and resistance is 9 ohms. So 4.5 divided by 9 is 0.5 ampere. So the current flowing through the resistors will be 0.5 ampere. The potential difference across each. So this is the current will flow through each circuit. So we'll multiply this with this resistance. So potential difference across 3 ohms resistance will be 3 ohms into 0.5 ampere, that is 1.5 volt, and potential difference across 6 ohms is equal to 6 ohms into 0.5 ampere, that is 3 volt. So 1.5 volt plus 3 volt is equal to 4.5 volt. So potential difference drop across resistor 3 ohms is 1.5 volt and potential difference across 6 ohms is 3 volt. Now put this into practice on page 214. Now this one, calculate the combined resistance of 1 ohms, 2 ohms and 3 ohms connected in series. So R1 is equal to 1 ohms, R2 is equal to 2 ohms, R3 is equal to 3 ohms. On addition, this is equivalent resistance is R1 plus R2 plus R3 is equal to 1 plus 2 plus 3 is equal to 6 ohm. 12 volt battery is connected across the resistor. This R1, R2, R3 is 12 volt battery. This is 12 volt battery is connected across this resistor. Calculate the current flowing through each resistor. So these resistors are in series, so the current will be same. So voltage divided by the total resistance. This is the effective resistance will be R1 plus R2 plus R3. So this R is basically R1 plus R2 plus R3, that is 6 ohms. So 12 volt divided by 6 ohms is equal to 2 ampere. So the current 2 ampere will flow through each resistor because they are in series. So same current will flow. So 12 ohms, 12 amperes. What is the potential difference across each resistor? The potential, the current flowing through this is 2 ampere. This resistor is 1 ohm. So the potential difference across this R1 is 1 volt. This is 2 ohms into 2. So this is 2 into 2 is 4. This is 4 volt. This is 3 ohms. So 3 ohms into 2 is 6. 3 into the 6 volt. So 6 volt, 4 volt and 1 volt. So this is 1 ohms and 2 amperes. So this is 2 volt. 2 ohms into 2 ampere is 4 volt and 3 ohms and 2 ampere is 6 volt. So same current is flowing 2 amperes. So multiply by the resistor, multiply by the resistor, multiply by the resistor, and this is 6 volt. So 2 volt, 4 volt and 6 volts are dropping across each resistor. So this resistor is 2 volt, this is 4 volt and this is 6 volt across this resistor. Since the circuit is in series, therefore same current will flow. So calculate the current flowing through each resistor, potential difference, and since the circuit is in series, same current will flow through each resistor. Calculate the combined resistance RA of 2 ohms and 3 ohms resistor connected in parallel. So 2 ohms and 3 ohms. 2 ohms and 3 ohms are connected in parallel. So this point is common, and there is a resistor across this point, and there is a resistance across this point. So they are in parallel. This point and this point is a common point between these two resistors. So this is a common connection. So in this case, the R equivalent is equal to R1 into R2 divided by R1 plus R2. So this is 2 ohms, this is 3 ohms multiplication, and this is 2 ohms plus 3 ohms addition. So this is 6 and this is 5. So 6 divided by 5, that's it. So the resistance, effective resistance will be lesser in this case, so resistance is 1.2 ohms. A 12 volt battery is connected across the resistor. What is the potential difference across each resistor? Calculate the current flowing through 2 ohms resistor. So the current is equal to V upon R1. So the resistor is 2 ohms. So divide 12 volt divided by 2 ohms is equal to 6 ampere. If a 3 ohms resistor is used instead of this R1, so this 4 ampere will flow. So the voltage is same. Now the resistance has increased, the current will decrease. Test yourself on page 214. Write down the equation for calculating the combined resistance of R1, R2, R3 connected in series. So this is R is equal to R1 plus R2 plus R3. So this is the equivalent resistance. And is the current in R1 larger, the same, or smaller than R3? Because they are in series, so same current will flow through each resistor. Write down the equation for calculating the combined resistance of R of resistance R1 and R2 connected in parallel. If they are connected in parallel, then this equivalent resistance would be R1 into R2 divided by R1 plus R2. If the resistance R1 is larger, the same, or smaller if R2 is R2 if R1 is smaller than R2. The smaller resistance will allow more current to pass through. Is the current in R1 larger? So the smaller resistance will allow more current to pass through. This is very simple in parallel combination. In case of series, the same current will flow.